Trig pre-college, trig functions. So in this video, we're going to cover some of the basic trig function concepts you've learned over the past couple of years. Things like the basic ratios for sine, cosine, tangent, and the reciprocal functions, secant, cosecant, cotangent, how to solve for a side using them, how to solve for an angle, so on. So let's jump right in. In the accompanying diagram of right triangle ABC, angle C is a right angle. Which equation is valid for triangle ABC? And so really they're just kind of testing your concept if you know what sine, cosine, and tangent, what their ratios are. So quick reference, that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And that's definitely something that at this point you should have memorized. Maybe you haven't thought about it in a couple of months, but it should come back to you pretty quick. You can use the SOHCAHTOA as a way to help you get through that. But this needs to be second nature at this point. So cosine A. Now, again, I guess I should recap. What do we mean by opposite, adjacent, hypotenuse, and stuff like that? Well, the longest side, in this case AB, opposite the 90-degree angle, that is the hypotenuse, no matter what. The hypotenuse is just the hypotenuse. It's never called opposite. It's never called hypotenuse. The hypotenuse is never called opposite or adjacent. It's only ever called the hypotenuse. The two legs of the right triangle, they are the opposite and adjacent sides, but that depends on which angle you're working with. So if I'm working with angle B, for instance, opposite angle B is across from the triangle. This would be opposite and this would be adjacent. However, if I switch my focus to angle A, then this would be the opposite across the triangle and this would be the adjacent. Again, the hypotenuse stays what it is. Opposite and adjacent flip-flop when you go from one complementary angle to the other. And that actually is an important concept that has to do with cofunctions, which we'll get into another time. But okay, so they want to know which of these is true. So let's take a look at them one at a time. So cosine A. So here's A. Cosine is adjacent over hypotenuse. So is C over B adjacent over hypotenuse? Well, here would be your adjacent side, and here's your hypotenuse. So cosine A would be B over C, not C over B. So this is upside down, so this is not the answer. How about tangent A? Well, I already have the adjacent and hypotenuse labeled for angle A. Opposite is opposite A. Notice that they're using lowercase a, opposite angle A, and lowercase b, opposite angle B, and lowercase c, opposite angle C. And that's what we do. We use capital letters for angles and lowercase letters to represent the sides opposite those angles. All right, so tangents opposite over adjacent. Opposite would be A, adjacent would be B. So that'd be A over B, not B over A. Again, this is upside down. Sine A is opposite over hypotenuse. Opposite would be A, hypotenuse would be C, A over C. That's it. That's our answer. Let's just check this last one. Cosine B, now this would be my adjacent side, and that would be A over C, not A over B, so that's definitely not correct. Which equation could be used to find the value of x in the right triangle shown? So again, you're using SOHCAHTOA here, sine, cosine, and tangent. I want to find side x, but what do I have? Notice that I have two sides and one angle. And so from this angle's perspective, x is my hypotenuse, and this side 12 is adjacent to it. The opposite side over here is not being used. So what function uses these? Adjacent hypotenuse, that would be cosine. And cosine of the angle, see what we were saying here is like sine A, that's sine of angle A, because you always go function, angle. So cosine of this angle, instead of calling it a letter like A, they're giving me a measurement of 20. So cosine of the 20-degree angle equals adjacent over hypotenuse would be 12 over x. And that's what I'm looking for here. Cos 20 equals 12 over x. See, every trig function is set up this way, that it's some sort of trig function, then an angle, because it's a function of an angle, like it's sine of an angle or cosine of an angle, and that equals a ratio. So make sure you write that down. Function, angle, equals ratio. Remember, this is the symbol theta. It's the angle symbol. Function angle equals ratio. And then the inverse of that would be an inverse function. And we're not going to get to this just yet, but I'm going to mention it now. Inverse function ratio equals your angle. So if you're solving for an angle, you have to do an inverse function of the ratio. An inverse function on that calculator is that second key, like the second sign, so on and so on. And we'll see that in a little bit. So now I could solve this by cross multiplying, but they don't want me to. They want me to on this one, though. This is set up for me. They're saying, what's the value of x? And so you just cross multiply. So exactly what you see here, I could put this over 1. X times 1 is x. 30 times sine 38. I want to write as 30 times sine 38. See, I don't do 30 times 38. I do 30 times sine 38. And that's what I'm going to type into my calculator, exactly like that. Now, I have to apologize to you because the computer I'm shooting this video on right now doesn't have that calculator I could pull up, so I'm going to do this calculation off to the side where you can't see, but you could definitely type it into your calculator. If you do 30 times sine 38, you should get 18.46984, so on, so on, so on, so on. And so to the nearest integer, whoops, change page, to the nearest integer would be 18. But let me write out that number for a sec. 18.4698. But the nearest integer would round to just be 18. Now, if you type this into your calculator and did not get that, my first guess would be that you're on radians. So if you go to mode, make sure your mode is set to degrees because this is a 38 degrees. We will talk about radians in another video. So that's how I could have solved for this x by cross multiplying here. This particular equation, if I cross multiplied this out of x times cos 20 would be x times cos 20 equal to 12 times 1 is 12. And then to solve for x, I'd have to divide by cos 20. So sometimes it's not just cross multiplying. Sometimes you also have to divide. So 12 divided by cos 20. And let's see what that is. Again, I'm going to type that into my calculator, which you can't see. But 12 divided by cos 20 is 12.77, so it comes out to be about 13. Which makes sense, and so it's, it's longer than the side that I have here, and so on. So set up a trig equation with sine, cosine, and tangent and the proper ratio, and cross multiply. You can find a missing side. This next one wants an angle measurement, and so that's slightly different. I want to find an angle here. So I'm going to set this up the same way, where the angle I'm using is k. I have two sides, and this is, again, 6 is my hypotenuse, and 5 would be adjacent to k. Opposite over here is not being used. So the function would be cosine. The angle we don't know is k, and it would equal the ratio 5 over 6, adjacent over hypotenuse. And so how do I solve for k? Well, if it was finding a side, I'd cross multiply like what I did here and here. But finding an angle, I have to use inverse functions. So this is what I have to do when I'm finding an angle. So let me rewrite that again over here, that I have to do inverse function of the ratio, and that will get me the angle. And so that would mean instead of cos k equals 5/6, I have to do inverse cosine of 5/6, and that will get me angle k. And so what you would type into your calculator then is the second cosine key, so inverse cosine of 5 divided by 6, and that should get you 33.557309, so on, so on, so on. But look at my answers. They want it in nearest minute. And so we have a, if you go to the angle feature in your calculator, and I'll show you how to do this in class because I can't pull it up on here, but if you go into the angle feature in your calculator, you can pull up something called DMS, stands for degrees, minutes, seconds. That'll convert that for you to the answer of A, but I'll show you that in class. And if I don't, just remind me that I want to show you how to do the DMS in class, because I can't do it in this video. Just take 2 seconds. It's really easy. And that's basically it. I want to do one more question. I know the video is about 10 minutes already, and that's always my target. So just bear with me one more minute. This last one is talking about cotangent. And so I just want to remind you that the reciprocal of sine is, I want to write this. The reciprocal of sine is cosecant. The reciprocal of cosine is secant, which is kind of opposite of what you would guess. You would think sine and secant, cosecant, but it's not. Sine and cosecant go together. Cosine and secant go together. Tangent and cotangent go together. These are reciprocal functions. What that means is, where sine is opposite over hypotenuse, well, cosecant is hypotenuse over opposite. So you just take the ratio and reciprocal it, flip it upside down. So this problem here, JT is 12, JM is 6, and this problem is actually pretty heavily involved for what I'm trying to do right now, especially because I'm kind of short on time. But if you did Pythagorean theorem here, you end up with this being, I guess I could go through the whole thing here. I was hoping for a shortcut. I could. There are other ways to do this with trig functions, knowing that this is 1/2, which means this is actually a 30-degree angle, and so on. I don't really want to overcomplicate things here for you. So Pythagorean theorem, I think you would understand at this point. So that'd be x squared plus 6 squared equals 12 squared. X squared plus 36 is 144 minus 144 minus 36 is 108, and so then you're doing x equals rad 108, which you would then need to reduce. And again, I'm going to shoot through this. It simplifies to 6 rad 3, so this is 6 rad 3. Cotangent J, well, I could think tangent J. Tangent J would be opposite over hypotenuse, and this is my opposite, opposite over adjacent. And so cotangent J, opposite over adjacent, that would be 6 rad 3 over 6, which can simplify to just be rad 3 over 1. But I'm not doing tangent, I'm doing cotangent, so I'd have to reciprocal it to be 1 over rad 3, and then rationalize it to be rad 3 over 3. So that's a tough one. It's a challenging one. Maybe we'll discuss that one in class 2 and questions like that. But we'll talk about that. Sorry for the extra long video tonight. I'll see you later.